Hi class, so today we're going to be talking about 2.3 and 2.4. First of all, let's start on 2.3, the chemistry of water. The shape of water and of all organic molecules is necessary to the structural and functional roles that they play in living things. The shape of a water molecule and its polarity make hydrogen bonding possible. A hydrogen bond is the attraction of a slightly positive hydrogen to a slightly negative atom in the vicinity. In CO2, a slight difference in polarity between carbon and the oxygens is present, but because carbon dioxide is symmetrical, the opposing charges cancel one another and the hydrogen bonding doesn't happen. Hydrogen bonding. Other biological molecules such as DNA have polar covalent bonds. In this instance, a hydrogen bond can occur within the same molecule or between nearby molecules. Although a single hydrogen bond is broken more easily than a single covalent bond, multiple hydrogen bonds are quite strong together. Hydrogen bonds between cellular molecules help maintain their proper structure and function. Similarly, the shape of a protein molecule is often maintained by hydrogen bonding between different parts of the same molecule. The hydrogen atoms in one water molecule are attracted to the oxygen atoms in other water molecules. Each of these hydrogen bonds is weaker than an ionic or covalent bond. The dotted lines show that the hydrogen bonds are more easily broken than any other bonds. Properties of water. The first cell evolved in water, and all living things are 70 to 90% water. Due to hydrogen bonding, water molecules hang on to each other, which ends up giving water unique chemical properties. With hydrogen bonding, water would freeze at -100 Celsius and boil at -91 Celsius, making most of water steam. Now we know that water freezes at 0 Celsius and boils at 100 Celsius. Water has a high heat capacity. A calorie is the amount of heat energy needed to raise the temperature of 1 gram of water to 1 Celsius. Water holds onto its heat and its temperatures fall more slowly than of other liquids. Because of this, organisms are able to maintain their normal internal temperatures and are protected from rapid temperature changes. Water has a high heat of evaporation. Water has a high heat of evaporation because hydrogen bonds must be broken before water boils. Water's high heat of vaporization gives animals in a hot environment an efficient way to release excessive amounts of body heat. Water is a solvent. A solution contains dissolved substance called solutes. Molecules that can attract water are hydrophilic. Non-ionized and polar molecules that cannot attract water are called hydrophobic. Water molecules are cohesive and adhesive. Cohesion refers to the ability of water molecules to cling to each other due to hydrogen bonding. A water molecule can form hydrogen bonds with at most 4 other water molecules. The strong cohesion of water molecules is obvious because water flows freely yet doesn't separate from each other. Adhesion refers to the ability of water molecules to cling to other polar surfaces. Because water molecules are attracted to each other, they stick together where the liquid surface is exposed to the air. The stronger the force between molecules in a liquid, the greater the surface tension. Frozen water is less dense than liquid water. As liquid water cools, the molecules come closer together. Water is the most dense at 4 Celsius. Any temperature below 4 Celsius causes hydrogen bonding to become more rigid and open. An example of this. Now we're going to move on to 2.4, which is acids and bases. When water ionizes, it releases an equal number of hydrogen and hydroxide ions. Acidic solutions. Acids are substances that dissociate in water, which causes the release of hydrogen ions. The acidity of a substance depends on how fully it dissociates in water. For example, hydrochloric acid is a strong acid that dissociates almost completely. Basic solutions. Bases are substances that are either take up hydrogen ions or release hydroxide ions. For example, sodium hydroxide is a strong base that dissociates almost completely. pH scale. The pH scale is used to indicate the acidity or basicity of a solution. The scale ranges from 0 to 14. 7 indicates a neutral state where the hydrogen ion and the hydroxide ion are on equal concentrations. A pH below 7 is acidic. A pH above 7 is basic. Here you can see an example of acids and bases. Buffers and pH. Buffer is a chemical or a combination of chemicals that puts the pH within normal limits. The pH of our blood is always about 7.4 when we're healthy. Normally, pH stability is possible because the body has built-in mechanisms to prevent pH changes. Buffers help keep the pH within normal limits because they are chemicals or combinations of chemicals that take up excess hydrogen ions or hydroxide ions. When hydrogen ions are added to the blood, this reaction reduces acidity. When hydroxide ions are added to the blood, this reduces base. We have reached the end of the video. I hope this helped you out with 2.3 and 2.4.